Hi, welcome to Lab 3. So in this tutorial, we're going to be doing a little bit more R work. We're going to work on plotting your results, and we're going to take a couple experiments in the PSYC toolkit which you worked in Lab 1. Let's go. So the first thing that we need to look at is the Lab 3 assignment. This will be available as soon as lab starts. Again, the goal of this lab is to further develop your statistical proficiency, your ability to interpret data, as well as your ability to plot data. The assignment is due tomorrow at 8 a.m. or the day after your lab at 8 a.m. And you'll be working in a group, and I will be randomly assigning you to groups of 3 or 4. Okay, so you'll still have roles. You'll have a manager, a recorder, and a spokesperson for this one. Again, remember that the recorder is supposed to share their screen throughout the entire time of the lab. So this is a person that maybe is a proficient in R or has R downloaded already on the computer. The first part is me participating in experiments. All 3 members of the group, or all 4 members of the group, will need to participate in both of the experiments before starting. Make sure to read these instructions, but I'm going to go through a quick tutorial. I'm going to show you how to participate in the flanker task. So, but make sure to read all the instructions. It's about 2 pages of instructions before starting. Okay. So if we click on this link, we get redirected to PSYC toolkit. You'll hit click to start. You'll see instructions. Read those instructions and then press the spacebar to continue. Now you should see a screen like this, and you'll hit spacebar to continue. Then you'll see a button to click Show Data, and then you'll actually see your data. Copy all that data and paste it into an Excel file. Here I have my data in an Excel file over here. And so here in this first column is the letters that are presented, whether they're congruent or incongruent, whether they're correct or not, and then what is the reaction time it took you to respond. So I have this set up in Excel, and I'm going to save it as a CSV file. So I'm going to click File, go down to Save As. It'll pop up here. I'm going to put it in my Downloads folder. I'm going to save it as flanker task. Actually, I'm going to put it as BS flanker task and put it as the .csv. I'm going to change this file format over here, change it to a .csv file. For the person who is the recorder or the screen share, they should be collecting all the results from all the group members and combining into one CSV task. You will then move it into R. So we're going to actually combine everyone's data and combine it into one file, then you'll move it into R. So let's click Save. It'll give you a little warning, it's totally fine. You hit yes. And so now we have a file name called BS Flanker Task that's located in our Downloads section. So if we open up R, I have R open up on my computer. I'm going to hit go to File, New File, put an R script. We always be using R scripts. And now I need to import the data. Again, if you want to use the point and click method, you're more than welcome to do so. I'm going to show you the reproducible method, which is typing out a name that you give your data. So here we're going to give our data a read.csv. So our name here is D. Then we're going to type in read.csv. We're going to give the file path name. So because I have a Mac, I can actually do a tilde, a backslash, downloads, backslash BS flanker task. Now make sure you spell this correctly, otherwise it won't work. So if I hit Command Enter, I will get my data, and then I can actually go look at it. So I have 50 observations of 4 variables. That looks about right. I have letters, congruent, correct, RT. Okay. So now you have imported your data into R, and now we can actually run some tests, do some descriptives. So let's first do some descriptive statistics. We also need to put in a couple of libraries. So let's add in library PSYC. And here's a new library that you might need to install. So if you don't have this library already on your computer, then you'll need to install. The code for installing a package is install.packages. You put the package in parentheses, so here would be plot2, and then command enter. I already have it installed, so I'm not going to actually do that, but you can go ahead and do that. So you see here I have library ggplot2, it shows up, so that means it's there. And so first thing I'm going to do is I'm going to put a describe function, and I'm going to describe the reaction time. Let's see what the average reaction time is for this task. The average reaction time here is a mean of 329.74 milliseconds with a standard deviation of 343.25 milliseconds. Okay, so let's look at our data, and we see that we have congruent and incongruent trials, and we have correct and incorrect trials. Remember, these are trials that are categorical in nature. There's either congruence or incongruence. It's correct or incorrect. Right now, they're listed as numbers. And if we go to our play button over here on the right-hand side, we can see they're actually listed as integers. So that might be a problem later on. What we can do is we might need to change the format of those files. So if we type in $, congruent, and we make it a character. Now instead of a listing as a number, R will recognize this as a character, which will allow us to put it as groups. And so now these are characters instead of integers. So if you notice there was int, now it's a CHR, and we're going to do the same thing for correct. So notice this int will change to a CHR. So $, correct, as dot character, $, correct. Again, correct is here. Now, we can actually use this as a categorical variable. So here I'm going to do a describe by function. And here I see that in group 0, we have 26 variables with a mean of 342. In group 2, we have, or group 1 rather, we have 24 with a mean of 315. Let's look at how well I did for this trial. And so I have an error because I misspelled describe by. So whenever you get an error, make sure to read that error and see if you can find out what the issue is. So here I have 33 correct responses and 17 incorrect responses and different reaction times. So let's try and do a t-test. We have an independent variable of correct and incorrect, so that's a categorical. We have a dependent variable of reaction time, so that's continuous. And we would like you to use the continuous reaction time variable as your dependent variable throughout this lab today. So if we do a t-test, t.test, I'm going to actually write it out as the dependent variable first, so $, reaction time, tilde, make sure you have this tilde here, $, correct. So I have the dependent variable, tilde, the independent variable, and I need one more command, that's var.equal equals true. What this is telling the computer is that we are presuming that the variance across both categories is equivalent. So here we have a 2-sample t-test, so we got the right sample t-test. We have a t of negative 0.86087, degrees of freedom of 48, and a p-value of 0.3936. So it looks like there's no difference in reaction time for trials that I got correct versus trials that I got incorrect. So now we're going to actually look at plotting the data. So plotting the data can be a little bit difficult, but it is a valuable tool to have. We're going to be using a package called ggplot, and one of the things that because we have a dependent variable that is continuous and an independent variable that is categorical, we may have some trouble with how to describe this data in a plot form. There's two options that we have. One is a box plot, which is fairly simple to do in R, but less visually appealing. And the other one is a bar plot, which is something that you guys might be very familiar with, but a little bit more difficult to do. We're going to do it in R, and I'm going to show you both functions. So the first is doing a box plot. I'm going to show you the simplest way to do a box plot, which is using a command called qplot. So it's called qplot for quick plot. And here we're going to do x equals, and here we have the x variable is going to be correct, y variable is going to be RT, your data equals D, and we're going to need a command called geom, which is telling it what is the geometric shape that you want it to have, parentheses, a box plot. Okay? So that is the simpler way to do it, but box plots aren't as interesting because we don't get that nice bar plot kind of feel. And so here we have a box plot, totally sufficient. You can see the mean, you can see the lower quartile, the upper quartile, the most extreme values on each of these correct and incorrect values. And now let's look at a bar plot. A bar plot looks to plot the means of each of the groups. So we already got the means of the reaction time by each group, correct and incorrect, in our describe by function. Let's rerun that and look at it. So we have a mean of 299.67 for group 1 and a mean of 388.12 for group 2. So that is, in the correct trials, I had a mean of 299.67 milliseconds. In the incorrect trials, I have a mean of 388 milliseconds. So what we need to do is we need to create a new data frame. So let's call this C. I'm going to type in data.frame. And here we need to set up each of our groups. So we're going to set up correct equals so here is the x variable. So here we need to have a C, because we're going to have two things we're going to put in this file, or in this data frame rather. So that it's going to be correct and incorrect. And then the other column of this data frame is going to be reaction time. Here we're also going to have two elements. So for correct, it's going to be 299.67, 299.67, and for incorrect, we have 388.12. Okay, we hit Command Enter there. And now we have a new data frame with corrects and RTs, exactly how we wanted it. So now we're going to actually go and do the bar plot. So what we're going to do is we're going to actually use the full ggplot function, where we're going to have to type in ggplot. First thing you do is type in ggplot, then you tell it where the data is. So in this case, it's C. And then we're going to also use a thing called AES. This is essentially telling it what the aesthetics are, what the x and y variables are. So here x equals correct, y equals RT. Then we go outside the parentheses, and this is where ggplot's a little bit different. We actually do a plus sign. And we type in geom bar. So this is a little bit of a different syntax than that qplot that we used before, but we're using the entire ggplot function. So we have geom bar. We're going to tell it a stat equals identity. And then position equals position dodge. Now, ggplot is one of the most universal plotting functions that people use in R. So if you have questions about this, please feel free to Google it. Please feel free to ask me. But if you are interested in plotting, and interested in R, interested in that you might use this in your future careers, this is a good plotting function to know. So here we have our ggplot. We have incorrect trials where we have that 99.67 mean, so that's correct. We have a 388 mean, so that's correct as well. Great. The last thing we need to discuss is operationalizations of variables. So one of the questions you're going to be asked at the end of this lab is, does this test operationalize the construct well? So let's talk about operationalization. Operationalization is strictly defining a variable into measurable factors. So the idea is taking an abstract construct. So maybe we're thinking about what is memory? Memory is an abstract construct. It's huge, it's gigantic. What are we thinking about? And so determining what tangible thing or behavior that we're using to measure or represent that thing and how to measure it. So here in this slide we have intelligence. Intelligence is a big abstract concept. What does intelligence mean? What components comprise of it? What are some examples of intelligence? How do we measure each of these components? So let's say we want to look at fluid intelligence, and we want to look at what are people's ability to take objects and rotate them in 3D. That could be one idea of intelligence. And so we could do a rotating task, and we have them do a cube and then rotate it and see if they can identify which is the correct rotation. That is an operationalization of a larger abstract concept of intelligence. So here in this lab, we're going to be asking you, what construct are they operationalizing and how are they doing it well? Thank you so much. Good luck on your lab assignment. I will see you in the next day or so.